Hey guys, today we're going to continue reviewing how to solve equations, and today specifically we're going to talk about solving radical equations or square root equations. Okay, now hopefully we remember from when we did this in class, the goal is to obviously solve for x, but it is trapped under a square root symbol. So in order to eliminate that square root symbol, we have to use a square power. Okay, now we also can't do the square power unless the radical is by itself on one side. So the first step that you should do when you're doing these radical equations is isolate the radical. Okay, and I do that by moving any numbers or coefficients that are not included within the radical. So in this case, I'm going to move the 3 to the other side, giving me 1. Now that my radical is isolated, I'm going to square both sides. And the reason that we do this is because square and square root are inverses of each other. They cancel each other out. So we do square once the radical is by itself so that we can cancel. But of course, what we do to one side, we have to do to the other. So 1 squared, we're lucky in this case, is just 1. This square on that side leaves me with just whatever is under the radical. And now we solve. So in this case, the only thing left for us to do is to subtract a 9. 1 minus 9 is minus 8. So we get x is equal to minus 8. Now, the one thing we need to remember about radical equations is that there cannot be negatives under the radical. Okay, so if there are any values of x that make the radical negative, right, which would be a complex number, we have to reject it as an extraneous solution. So the last step for these problems are check for extraneous solutions. Okay, check for extraneous solutions. So how do we do that? We just plug it in. So 4 is equal to the square root of minus 8 plus 9 with a plus 3 on the outside. This becomes minus 8 plus 9 is 1. The radical itself is always assumed to be the positive of the radical, right? Unless there is a negative in front of it multiplying. So square root of 1 in this case will just be 1. And here we see 4 is equal to 4. So x is a solution. It is not extraneous. But remember, for these, we always want to check. So let's continue. We have something a little bit more complicated here, okay? We have a few more terms. We have an x term. The rules stay the same, okay? We're still isolating our radical by adding this 9 to both sides. And we're still squaring both sides. Now, where is this question more complicated than the last? Well, yes, this comes out of the radical exactly, but x plus 2 squared is x plus 2 times x plus 2. So that means we have to FOIL out this binomial. We cannot distribute the power because of the plus. So when we FOIL this out, we get x squared plus 2x plus 2x plus 4, giving me a final result of x squared plus 4x plus 4. Okay, so now we see the square power, so we should be thinking quadratic. So how do we solve quadratics? We have to set it equal to 0 and first try factoring, and then if not, complete the square. So I'm going to start by moving this 6x and this 7 to the other side. Okay, and I do that to put it in standard form, equal to 0 for factoring purposes. So plus 4 minus 6 is minus 2x, plus 4 minus 7 is minus 3. So now it is a trinomial where a is equal to 1. I'm looking for two numbers that multiply to negative 3 and add to negative 2. That is x minus 3, x plus 1. X, each factor is equal to 0, so that leaves me with x equal to 3 and x equal to -1. Now, the last and final step is to check for extraneous solutions. Now, we could do this by plugging in the 3 to each, right? 6 times 3 plus 7 minus 9, 3 minus 7. And you should do that if you're ever given a paper test where you have to show all of your work. We would have to do that for the second one as well. And if it works out to be true when I evaluate both sides, we know it would be a solution. However, I'm going to teach you a trick to kind of help move these questions along a little bit, okay? We know we have our graphing calculator. We know we can do some great things with it. So what I want you to do is I want you to think of this as two equations. We have the left-hand side equation, and we have the right-hand side equation. We want to see where these two are equivalent, okay? So one way of doing this in your calculator is to do it as a systems of equation where this is my y1 and this is my y2. What are solutions to systems of equations? The point of intersection. So let's see. How do we check this by graphing? Well, the first thing you're going to do is you're going to plug in the left-hand side into one of the y's and the right-hand side into the other. Okay, so that's what it says in number 1. Enter each side of the equation into different y equals. Then we're going to go to second trace and choose option number 5, intersect. And we do that because we've now created a system of equations. Okay, now press enter, enter, enter. With the square root, you have to be careful if you're too close to the end. You may want to move the cursor a little bit, but it should be able to give you your point of intersection. So now looking at these points of intersection, what's important here? Well, we know we don't have a y value. We're looking at our x value here. We're looking for the x value that makes these equivalent. So you'll notice that those two numbers are the same two numbers we got here, meaning that neither of them are extraneous. We would see that they're extraneous if there was no point of intersection at a particular x value. Okay, now in order to get these two different points of intersection, please remember you're going to have to do this twice and move the cursor closest to the point that you want. Okay, so for the rest of this document, we're going to be checking using our calculators. Okay, so let's continue solving algebraically and then check it on our calculators. So what do we need to do here? We need to isolate our radical. That's done for us, right? So we now square both sides. On this side, it cancels, leaving 8x by itself. On this side, negative x times negative x, well, the negatives cancel, and we're just left with x squared. So now I'm going, since I see it's a quadratic, I'm going to set it equal to 0 so that I have the opportunity to factor. All right, so we have a GCF here of x with leftover of x minus 8. And we set each one equal to 0. So we have x equals 0 and x equals 8. So now we need to check for extraneous solutions. So what are we plugging in? One of the y equals is going to be negative x. The other y equals is going to be radical x. Second trace, intersect, enter, enter, enter. And we see our picture that looks like this, right? We have an intersection at x is equal to 0. So now we know that this is not extraneous, so we're good here. But what about the x is equal to 8? Well, if we look at our calculators, right? 1, 2, 3, 4, 5, 6, 7, 8. We do not see a point of intersection. In fact, we know this graph's going to continue going that way, and this graph's going to continue going that way, so it's impossible for them to ever come back and intersect. So what does that mean? Well, that means that this is an extraneous solution. okay, we're going to reject it. If we were plugging this into delta math, we would only put x is equal to 0. Okay, we would reject the 8. All right, so that's how we're going to handle our extraneous solutions. So let's continue. Solving radical equations again. We need to isolate a radical. Subtract a 5. Excellent. 5x minus 5. Okay. Square both sides. Excellent. Minus 5 is equal to 25. We add a 5. We divide by 5, and we're left with x is equal to 6. So now we have to check, is this extraneous? So we graph it. And something interesting happens here, right? Well, remember, when I plug this into y equals, I actually plug this whole thing into y1. And I actually just plugged in 0 for y2. And you're allowed to do that. Okay, what does it do? It gives me this horizontal line along the x-axis. So now our answer in our solution that we found was x equal to 6. 1, 2, 3, 4, 5, 6. That's here. It is very clear that these two do not intersect. In fact, they don't intersect anywhere because this is going to continue up and this is going to continue out. Remember, square root has a limited domain, so it ends at that point. So what does this mean? Well, this means that we have to reject this. This is extraneous. So what is my final answer here? Well, it's no solution. Okay, now if you're typing into delta math, it may not accept no solution. What it may accept is something called the empty set, which would be either an empty set of brackets, or sometimes they'll do a 0 with a slash through it. That means that there is no solution. It is an empty set. Okay, so let's try one last example. Kind of complicated on this round. This is the most complicated you possibly could ever see. And why is it so complicated? Well, we have two radicals in this question. So the question is, which one do we isolate first? Technically, it should not matter. You should get the same answer. But I always isolate the biggest radical first. And that's just because we want to try to make things less complicated rather than more complicated, okay? So I always isolate the biggest radical first, which is already done for us right here, okay? And I square both sides. Great, great. We get x minus 8. Now, here's our issue. Now we have radical x minus 2 squared. That is a binomial. One of which is a radical, one term which is a radical, and one's a constant. That means I am multiplying it through FOILing, right? Because of the subtraction in between. So when I do that, I have to multiply the first term. So radical x times radical x. Remember, if it's the same underneath, it becomes free. Minus 2 times radical x. Minus 2 times radical x, and then a plus 4. These two, if you remember, are like terms because they are like radicals. So that's a minus 4 radical x plus 4. That cannot be simplified any further. So this entire expression is what I replace the left-hand side with. So now we have a new radical equation. We still have one in there, so guess what we're going to have to do? Isolate it again. So to do that, first I'm going to do any addition or subtraction that's in the way. Okay, I'm actually going to move this over. So what addition or subtraction do I have? Well, I'm going to subtract this x to that side. I'm going to subtract this 4 to that side. This cancels. This cancels. Oh, and even luckier, these two cancel, and I'm left with a minus 12. Now, this negative 4 on the outside is a coefficient. I want to divide by that entire coefficient, including the sign, and I get canceled sign 3. Now, my radical is isolated, so I square both sides. These two will cancel, and I get x is equal to 9, okay? So Now I have to check if that is an extraneous solution. So what am I plugging into my calculator? Well, let's plug this into y1, this into y2, second trace, intersect. Now I did have a little bit of trouble getting the cursors where I needed it to be. Remember, you can press the arrow keys, to keep shifting over till you're closer to the point of intersection. Okay, but I did eventually get x is equal to 9, which means that this is not extraneous. That is a valid solution. All right, so that's a little bit of a review with a little bit of calculator help to make this